Okay, guys, we're ready to start into Chapter 5. And Chapter 5 is all about exponents. So we're going to focus today on zero and negative exponents. Things you don't want is really what we're getting at here is when you're simplifying exponential expressions, you don't want negative exponents and you don't want zeros as exponents either. But before we dive in, let's just remind ourselves what exponents are. So here I've got 2 to the third. Now, the big number, that is the 2 here, is known as the base. Okay? The little number, the 3, that's known as the exponent. And the whole thing combined is known as a power. Now, we often use the word power and exponent interchangeably. Like, you'll hear people say this is 2 to the third power. Okay? So that's okay if you're doing that. Just know that it's interchangeable. And let's remember what 2 to the third means. 2 to the third is repeated multiplication. Okay, so 2 to the third means 2 times 2 times 2. So we're multiplying 2 3 times, which is 8. Okay, 2 times 2 is 4 times 2 is 8. What this does not mean, and is a very common mistake, is students, because they're in a hurry, thinks that means 2 times 3. Okay, so this is not what you want to do. All right? So keep that in mind. Now, let's look at patterns for a second. So I've got 2 to the fourth, then 2 to the third, then 2 to the second, and then 2 to the first. All right? So you can see the pattern is the base is staying the same, but the exponent's going down by 1 each time. Well, 2 to the fourth, 2 times 2 is 4 times 2 is 8 times 2 is 16, right? 2 to the third, we just figured out was 8. 2 to the second, 2 times 2 is 4. And 2 to the first is 2, all right? So if we look at this as a pattern, we can see the exponent's going down by 1, and the answers, it's being divided by 2 each time, right? 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, and the next one is, what would 2 to the 0 be? Well, 4 divided by 2 is 2, 2 divided by 2 is 1, okay? So anything, any number to the 0 power or to the 0 exponent has a value of 1. And that leads us to our first rule right here. Any number to the 0 power equals 1. Okay? All right, let's keep going. Now, if we keep going in this pattern, we now have 2 to the negative 1. Well, 1 divided by 2 is 1/2. 2 to the negative 2, well, 1/2 divided by 2 is 1/4. 2 to the negative 3, if we keep this pattern going, that's 1/8, because half of a fourth is an eighth. And we can keep going and see that 2 to the negative 4 is 1/16. Now I want to expand on these exponents a little bit. So I'm going to zoom in. Okay, I can rewrite 1 over 2 as 1 over 2 to the first power. I can rewrite 1/4 as 1 over 2 to the second power. I can rewrite 1/8 as 1 over 2 to the third power. And I can rewrite 1/16 as 1 over 2 to the fourth power. Now what I want you to notice is that the exponents on these two match up with the original exponent, except it has a different sign. So 2 to the negative 4 is 1 over 2 to the positive 4, okay? One thing we want to remember when we're simplifying expressions is you never want to leave a negative exponent in your expression. So that leads us to our next rule, which is any number to a negative power is equal to 1 over that same base to the positive version of that exponent. The reciprocal, or not reciprocal, the opposite of that is if I have 1 over a to the negative n, see now it's in the denominator with a negative power, so I move it to the numerator and that's a to the positive n, okay? So these are things you're going to want to memorize, okay? It's any number to the 0 power is 1, and you always want to get rid of negative exponents by either moving it from the numerator to the denominator or from the denominator to the numerator. And let me expand on that. You can think of a to the negative n as over 1. So when I talk about it being in the numerator, that's what I mean. And here, obviously, a to the negative n is in the denominator. And I can think of a to the n as now being in the numerator. Okay? All right, let's take a look at some examples. And since we're adding to your toolbox, that's the category for the day. So we have example hammer. Okay? It's a really simple example. It's just to drive home that I've got 342 to the 0 power. Well, like I said, any number to the 0 power is 1. So my answer here is very simply 1. And again, any number, and let's use a different variable, n to the 0 power is 1. So even a variable to the 0 power is equal to 1. You don't have to know what the variable is. You know it's going to be an answer of 1 if it's being raised to the 0 power. Let's do another example. What's another thing in a toolkit? Screwdrivers. So we have example screwdriver. Okay, and this example is 2 to the negative 6. Well, we don't want to have an answer with a negative exponent. So if I think of this as being in the numerator, all I have to do is flip this fraction over and make that to the positive 6 power. It's just that easy. Look, 5 to the negative 3 equals 1 over 5 to the positive 3. And if you want to, you can expand it, 1 over 125, okay? But notice, no more negative exponents. If I have 1 over n to the negative 3, I have to get rid of that negative exponent, so I move that to the numerator, and that's n to the positive 3. Obviously, I'm not showing the over 1. You don't need to. And if I have 1 over 4 to the negative 3, I'm going to move that to the numerator, and that becomes 4 to the positive 3. Okay, so very quick and easy examples. What's another thing in a tool chest? Pliers. So let's do example pliers. Example pliers. Okay? So now we're going to start mixing it up a little bit. So I've got 5 to the negative 2 over p. Now, that negative 2 exponent only applies to the 5. It does not apply to the p. So we have to move this 5 to the negative 2 into the denominator and change the sign of the power. Okay, so this whole thing is going to slide down here to the denominator and become 5 to the positive 2. P doesn't change. We need something in the numerator, so we're going to put 1. Okay, and you can go a little further if you want to. That would be 1 over 25p, because 5 squared is 25. What if we had a problem like 3x to the negative 2 over y? Okay, a lot of times people think that the negative 2 applies to the 3 and to the x, but that's not true. That negative 2 only applies to the x. So this, the x to the negative 2, has to drop down to the numerator. The 3 stays where it was. So that stays in the numerator. And now we've got x to the positive 2, and the y is there. Okay? Note, I drew the arrow like I was going to put the x behind the y, but when I'm done, I typically want my variables in alphabetical order. Now let's change this problem a little bit, and let's go 3x to the negative 2 over y. Okay, now that negative 2 does apply to the 3 and to the x. Okay, so this whole thing needs to drop to the denominator, and I've got 1 over 3x squared y. Notice that's a positive 2 now. And you can simplify that. If you think of 3x squared, that's 3x times 3x. which would be 9x squared, because everything's multiplication. So you could even simplify this as 1 over 9x squared y. Okay? Let's look at another one. A wrench. So this is example wrench. Okay. Now we're going to step it up even a little bit more. We've got 6a to the negative 1, c to the negative 3 over b to the 0. All right, let's think about what's going to happen here. Well, first off, I'm going to take care of the easy one. Any number to a 0 power is 1, so this is just 1. Okay? Now, a to the negative 1 needs to drop down, and c to the negative 3 needs to drop down. The 6, nothing told me to move the 6, so the 6 stays in the numerator, over, I brought a to the negative 1 down, making it a to the positive 1. I don't need to put the 1. A to the first power is a. And then c, what was a negative 3, now becomes a positive 3. And that's your answer there. And then we can go just a little bit further. Example vice grips. Okay. And you've got 3a to the negative 2, c to the negative 3, over d to the negative 2. Now what makes this difference is we're going to be moving things from the numerator to the denominator and from the denominator to the numerator. So a to the negative 2 needs to drop down, c to the negative 3 needs to drop down, and d to the negative 2 needs to move up. And that will get rid of all the negative exponents. So this becomes 3. 3 had no reason to move. Over, oh yeah, I brought the d negative 2 moved upstairs, so that's d to the positive 2. A to the negative 2 in the numerator becomes a to the positive 2 in the denominator, and c to the negative 3 in the numerator becomes c to the positive 3 in the denominator. All right? So, big takeaway here. Any number to the 0 power is 1. And you now have these tools to get rid of negative exponents. And we looked at some very simple examples, and then we kind of cranked it up a little bit, looked at some things that were a little bit more complicated. Okay? Go slow on these problems. Think about it step by step by step. These